previous discussion itself I told you there will be three steps. First one is um, feature extraction, second one is segmentation, third one is classification. And in our project we will not be doing segmentation, we will be doing only feature extraction and then classification. And for classification, if you see, if it is ML algorithm, we have to extract the features and classify. If it is deep learning, directly input data we have to give and the classification will take place. Classification will directly take place if it is deep learning. Already I told you this. We will take the database, okay, dataset input file, then feature extraction, then we will apply to the machine learning, where we will have the ML classification algorithms. If we are doing deep learning, directly input data will be given, and the output of all this classification algorithms, we will have accuracy, sensitivity, selectivity, specificity, F1 score. And the classification output will be confusion matrix, and from the confusion matrix we can, so we will get confusion matrix like this, 2 by 2 matrix. It is true positive, true negative, false positive, false negative. And here are the details, what is true positive, true negative. And then using that we will be calculating accuracy formula is there, sensitivity, selectivity, specificity, F1 score formulas are there. This will be the output of classification algorithms, whether it is ML classification algorithm or DL classification algorithm. Okay. And last time I think you can note down this point. Last time I think they asked you why you are putting a DL, okay, in the heading, in the PPT, in the title, why you are putting a DL. You can put ML because DL is a subset of ML. This is the question last time they pointed out. But in the PPT just now I showed you, ML the way of working is different, DL way of working is different. For ML we have to extract the features, only then we have to apply for the SVM. But for DL, CNN, convolution neural network, for DL, deep learning, okay, DL means deep learning, ML means machine learning. So for deep learning we have to give the input file directly without feature extraction. So they work in different methods, okay, they work in different methods. Though they are subset, okay, though they are subset, we cannot simply combine them like that. We are using in our project both the types of algorithms. That's why we are putting the heading ML and DL separately. Okay, we are putting the heading ML DL separately because this is the diagram. If you see, this is the diagram. Artificial intelligence is the outer one, big one. Artificial intelligence is the outer one, big one. Okay, and ML is subset of artificial intelligence. ML is subset of artificial intelligence. Deep learning is again subset of artificial intelligence. And data science means there is some overlap between all these three and the data science. It is a blend of algorithms. It discover hidden patterns from raw data. It is data science means it is blend of algorithms, discover hidden patterns from raw data. Okay, it will have some overlap with this, but data science also have something which is out of this. Okay, and machine learning, it can give output only with the linear operations. It can do only linear operations. SVM is a linear classification algorithm. Okay, logistic regression also linear classification algorithm. And in our base paper we have naive bayes algorithm, decision tree algorithm. All these are, they can work with the linear equations only. Okay, linear equations, linear classification algorithms. But deep learning, it can work with multiple nonlinear operations on the data. It can work with multiple nonlinear operations on data. So this is the difference. And AI, artificial intelligence, means it is the capacity of a machine to learn and understand. Okay, so here we have many things, subset like that. But the way of working is different. Machine learning, it can work. This is the difference between machine learning and deep learning. For applying deep learning, the input data should be very large. For a small input data, we can apply machine learning. Feature extraction is required in machine learning. It is not required in deep learning. Number of algorithms are many in machine learning. Very few algorithms are there in deep learning. CNN, convolution neural network, we are going to use. That is deep learning algorithm. Okay. Training time. while execution we will have training, testing, something like that. So training time is very short in machine learning, training time is very long in deep learning. There are so many differences between them. Simply we cannot say SVM is a deep learning algorithm, okay. Because we are using SVM separately, CNN separately in our project, we cannot put the title as deep machine learning. Okay, though deep learning is a subset, we are using both the algorithms separately in our project. That's why we have to give the title separately only. Why they are telling it is a subset, you should give ML only in the title. This is the reason. But in depth, technically there is a lot of difference between ML and DL. So in the title you can justify that, you can put both the names because you are using those different algorithms. That's the reason you wanted to put, you can tell like that, you wanted to put, because this algorithm SVM cannot be called as DL, CNN cannot be called as ML algorithm. We are using them separately, and that's the reason we wanted to put the heading separately. Okay, that is one point I want to stress. And then in the block diagram, they told you block diagram is not clear. Last time they told you block diagram is not clear. If you see the block diagram, there is nothing like clarity and all. Okay, there is nothing like clarity and all. The base paper, similar block diagram only you have put in the PPT. This block diagram only you have put in the PPT. Okay, they are also given it as model diagram. Okay, you can change it instead of block diagram, you can rename it as model diagram. Don't put proposed, don't put the word proposed, you can just put model diagram. Okay, what we will do, we will take the diabetes patient data, then we will pre-process our feature extraction one and the same. We will do feature extraction, then we will apply on the ML algorithms. We will apply on the ML algorithms. If we are using CNN deep learning algorithm, directly from the input you have to give the arrow mark. That while explaining you can explain. Okay, and then we will get the performance evaluation, means we are getting accuracy, precision, sensitivity, F1 score, like that. That will be the output. Then comparative study means SVM you are getting accuracy, logistic regression also you will get accuracy, CNN also you will get accuracy. Which accuracy is better, that comparison you are doing on the result, and that will be the final result what you will present. The base paper also they have compared like that only. Okay, so why the block diagram is not clear, I don't understand. You see table 7, you see table 7, table 6 is just the formulas. Okay, these formulas already I discussed, I showed you many parameters also I showed you. Apart from this, if you remember, this the thing, formulas, entire matrix formulas I have showed you. Next I am going with the table 7. Table 7, if you see, this is the comparison analysis. What comparison you are doing means, this is the comparison analysis what you are going to do. Objective we will slightly modify, you kindly remind me. Again when we put the PPT, objective I will try to slightly modify. Other than that, block diagram is very clear. I explained you now the block diagram. We are taking the input, we are pre-processing, or feature extraction is done, then classification we are applying. Okay, after classification we will get the metrics, performance metrics. Because 2 3 algorithms we are using, we will get accuracy itself 2 3 values, precision 2 3 values, different algorithms are there. So finally we will put a tabular column like this. In the PPT also just now you have put, for SVM and logistic regression you have prepared the table. That is the comparison what we are going to do. If you see in the base paper, they are getting the maximum value 76.3 only. Using naive Bayes they are getting 76.3. Okay, but presently you compare your two algorithms, whether it is greater than the base paper, it is good. Okay, now this is about the block diagram what I want to